All right, in this video, we're going to be taking a look at Projectile Practice 3. Remember, we got those 4 equations that we are going to be using. One is for horizontal. We got 3 equations for vertical motion. So you can have those in your notes next to you. Our first question here is if a baseball is thrown at 20 meters per second straight up into the air, what is the velocity when the baseball comes back to the height it was thrown? So I like to draw kind of pictures here. There's this guy. He's throwing a baseball. The initial velocity, here we go, Vyi, is going to be 20 meters per second. So he's thrown it up. And if we want to kind of imagine the path, it is straight up. So it hits a peak, comes back down, and he catches it. So it doesn't matter how tall this guy is. If we consider the starting point yi equals 0, yf, the final height, is also going to equal 0. So we can use this equation, the one with velocity squared equals Vyi squared plus 2 times the acceleration yf minus yi. From here, we can start plugging numbers in. The initial velocity, 20 meters per second. The acceleration is gravity, so we could add that down here. And gravity is going to be negative 9.8 meters per second squared. And I guess these are going to be positions, so those are meters. And this whole term right here, we could plug a in here, but yf minus yi, 0 minus 0, that equals 0. So any number times 0 would be 0. So from here, we could get, we'll move it over here. Vyf squared equals 400. Take the square roots of both sides. And this is where you got to use your brain, because it could be 2 answers. It could be 20 meters per second, or it could be negative 20 meters per second. And we know that when we started, this was our positive direction, and it's coming back down, so we should know our answer is negative 20 meters per second. Question number 2. A pitcher pitches a baseball completely horizontally at 40 meters per second. If the distance between the pitcher's mound and home plate is 18.44 meters, how much does the baseball drop vertically as it crosses home plate? So I'm trying to find how much it crosses, how much the baseball drops vertically as it crosses home plate. So I'm looking for, the final y position, yf. And there's always, well, not always, but usually there's more than one way to solve these questions. The way I'm going to solve this one is I'm going to think, how much time does it take this baseball to go across home plate? So I have my equation over here. The change in horizontal position is equal to the horizontal velocity times the time. We know that the horizontal position is 18.44 meters. And we know our horizontal velocity, assuming no air resistance, is 40 meters per second. So to find time, you divide both of these by 40 meters per second. And we get t is equal to 18.44 divided by 40, or around 0.46 seconds. So now that we have time, the equation we can use, we'll say this is what we're looking for. Turns out that YF, that final position, is equal to YI plus VYIT plus 0.5 AT squared. We can call the initial position 0. That could be our starting position. And then YF would be how much it dropped. It was thrown completely horizontally, so our VYI is also 0. And our A is our acceleration from gravity. So 0.5 times negative 9.8 meters per second squared times our time, which we just found, excellent, 0.46 seconds squared. So 0.5 times 9.8 or negative 9.8 would be negative 4.9. And over here, 0.46 squared. 0.46 squared is, I want to round it, 0.2116. Maybe I won't round it. So now I just got to multiply those two numbers, and I get how much it dropped. It went down about 1.04 meters in distance as the ball was going from the pitcher's mound to home plate. And we got one more question here. A soccer player kicks a ball. Let's draw a picture over here. Here's a little soccer player. They're going to kick a ball. Oh no, I messed up. I just drew this person as an X. They're going to kick the ball. It's going at a 32-degree angle, so we'll call that 32 degrees, at a 7.8 meters per second velocity. So the first thing I'm going to do is I'm going to break this down into its components. So if this was 32 degrees and 7.8 meters per second, I want to find my X component. This will be 7.8 cosine of 32, or about 6.6. We'll call this Vx equals 6.6 meters per second. That's its speed in the horizontal direction. And in the vertical direction, this is going to be 7.8 sine of 32. Or we could say Vy equals about 4.1 meters per second. So when it asks, find the time the ball will be in the air, so we can imagine the trajectory. Let's move this over so we got room. We can imagine our trajectory is like, makes a parabola, bloop, pops back down. So the time the ball was in the air is the time between when YF equals 0 and when YI equals 0 and when YF equals 0. So I think the easiest equation to use here would be this one. YF equals YI plus VYIT plus 0.5 acceleration t squared. And we could start plugging our numbers in. If you start at ground level and it hits at ground level, YF equals 0, YI equals 0. We calculated our initial velocity in the y direction. Sorry, we only care about the y direction. 4.1 meters per second times the time. I'm going to right away multiply my acceleration by 0.5 right here. The acceleration due to gravity is negative 9.8. So if we multiply that by 5, it is negative. Sorry, I'll turn this into a positive. It'll be a negative 4.9. and then t squared. So we can kind of simplify this a little bit. 0 equals 4.1 t minus 4.9 t squared. We'll add 4.9 t squared to both sides. And you get 4.9 t squared equals 4.1 t. Now the next step is divide both sides by t. I'm going to do it all in one step. By 4.9t. When you divide it by 4.9t, on this left side, you're left with only the time. And on this right side, the t's cancel out, and it's just 4.1 divided by 4.9. And when we do that, 4.1 divided by 4.9, we get about 0.84 seconds of hang time. So that's our answer for A. Next, it asks, find the maximum height of the ball. So when we're looking for maximum height, we have to remember that right here at our maximum height, VYF equals 0 at that height. So we could use that to our advantage when we're trying to find that height. And we can plug in some numbers to our other equation to get there. So because VYF equals 0 is what we're going to use, we'll plug it in down here. VYF squared equals VYI squared plus 2A YF. That's our final height. That's our max height right there, minus YI. YI is the ground level. It's going to end up being 0. We'll plug that in a second. VYF, remember it's velocity, it's vertical velocity at that max point is 0. So this will be just 0. Equals VYI squared. It's going to be 4.1 squared. A is our gravity, so negative 9.8. So here I'm just going to put in 2 times negative 9.8 is negative 19.6. So I'm just plugging that A right in there and multiplying it by 2. And then here, YI equals 0. So this just turns into, YF, or that maximum height. From here, I'm going to add 19.6 YF to both sides, plus 19.6 YF. And it ends up looking like this. 19.6 times the max height equals, what's 4.1 squared? 16.81. Our last step, divide both sides by 19.6. And we get an answer, maximum height, or YF, equals 0.86 meters. All right, that is B. Let me make sure everything is on screen here. Now we got C. How far will the ball travel? Oh, another typo. Classic. All right. This should say far. How far will the ball travel horizontally when the ball hits the ground? So I am looking for the delta x right there. So anytime you hear horizontal, you always got only one equation. It is going to be delta x equals x velocity times time. We're looking for a delta x, so we're just multiplying our horizontal velocity, 6.6 meters per second, times the time, which we found right there. That's when it hits the ground, 0.84 seconds. And our delta x equals, after multiplying those two together, the ball only travels about 5.5 meters before hitting the ground again. We definitely want to study these type of questions because those are the main things I will ask in a projectile. So it's a good question to practice.